Hello everyone, welcome to the session on Linux operating system. So this is going to provide you some of the most important concepts of Linux operating systems as well as hands-on commands. We will log into a Linux system and then we will look at some of the most important commands that you need to be aware. So one of the main reasons for this video, this is not an all-inclusive video of the entire Linux operating system. The focus for this session is some of the students who attend interviews, right? They need to know the fundamentals of Linux so that they are comfortable answering the questions there. That's the purpose of this video. So let's get started. So Linux as such, it was founded by Linus Torvalds back in 1991. He was Finnish. And it's an open source, it's free. You can download the latest version, install, and without any cost, you can use the entire operating system. It's multi-user multitasking. That means it can do multiple tasks at the same time. Many users can use the system at the same time. That's the advantage of Linux. It comes in multiple flavors: CentOS, Ubuntu, Debian, Fedora, right? There are multiple versions, Red Hat. So many versions come in. So you can use the one that you're comfortable with. If you look at the layers of Linux, right? So the base is the hardware. You have a core hardware that's available. On top of it, you have the kernel. The kernel is the core operating system, right? This is the kernel. On top of it, you have the shell. So Corn shell, Bone shell, C shell. You have multiple shells available on which you can run shell scripts as well. So this provides the user interface where you can type the commands on the command line interface, right? That's the shell. On top of it, you have the graphical user interface, which is very similar to the Windows systems that you've used, right? It provides the GUI front end. And above that, you have your applications that you run. So this is the different layers, right, that you have in Linux. And typically, right, you interact with the applications using the graphical user interface. Now, when you look at what are the different aspects of Linux operating system that we need to be aware of, these aspects are pretty common to all other operating systems as well. So let's look at them. One is memory management, scheduling, file system and authorization, authentication, input-output, and network management as well, and process management. So these are primary aspects. There are definitely multiple other aspects that we have to deal with, but these are the major components of any operating system, and Linux is no exception. So let's look at one at a time. We'll start with scheduling, right? So the scheduler process gets kick-started when Linux starts itself. So we look at Linux kickstart process in a very short time. Before that, scheduling is responsible for making sure that each process gets enough time. This is what is ensuring the multitasking capability in the Linux kernel. So that's the scheduler. File system and authorization. So file system is having all these files across different folders, ensuring authentication, authorization, ensuring the file permissions are perfect, and Linux maintains a unique user group and others kind of permission. We'll talk about all these things in the coming slides, but as of now, right, this needs to be managed in Linux. Input output, that is like from the keyboard, from the disk, from the monitor to the monitor, all these things, right? That's input output management, and managing the networks, right? So we have which has to go through socket, message pipes, inter-process communication. All the methodologies have to be maintained. Process management, maintaining the process, different process, their PIDs, scheduling of the processes. These are the components which are part of any operating system, not necessarily Linux, and Linux is no exception. The different aspects are memory management, scheduler, file system, authentication and authorization, input output and network management, process management. These are the primary aspects. Of course, there are other aspects in Linux like inter-process communication and others, but primarily these are the aspects which we need to talk about. So first is memory management is responsible for virtual memory management. Scheduling is responsible to make sure that every process gets enough CPU time. This actually drives the multitasking capability in Linux kernel. File system manager is responsible to make sure that you have files, folders, and each file is given the right permissions That's file system manager's responsibility. Authentication, authorization to ensure that the login ID, password, everything is managed. Input output, which ensures that you're able to send and receive to the Linux system, right? Keyboard, monitor, printer, all these things, as well as the network management, right? Where a Linux has to communicate with other systems on the internet. Process management, you have various processes running at any time because it's a multitasking system. So many processes would be running at any point of time. So process management is a very important aspect. We'll talk about each of these aspects and the corresponding commands associated with them, and that would be the next part. But first, let's start with what is really happening during a Linux booting, right? When you power on the system, what really happens, right? So first, irrespective of the operating system, the BIOS is the one that loads. BIOS is basic input output system, which ensures that at least the basic things are working and they are in order, right? Before it starts the next step. BIOS transfers control to the MBR. MBR is the master boot record, where the information about the kernel and which operating system to boot, all this information is available. From there, grub, earlier it was called Linux loader or Lilo, now it is grub. So grub takes over from here. So grub means Grand Unified Bootloader. Grub is responsible to load the kernel image into the RAM, and after that it transfers control to the kernel, right? So kernel is basically the Unix operating system. So this is the core operating system, right, which has scheduling, memory management, all this put together is the kernel. The whole disk that we saw in the earlier slide, that's what is the kernel. The kernel gets loaded, and then finally, once the kernel image is completely loaded, it transfers control to the first process. PID 0 is basically demand paging, or the pager, which is responsible for memory management. That gets kick-started, and then init is process ID 1, which actually initializes and kickstarts the Linux operating system. Finally, right, this init actually decides what is the run level in which the Unix has to start. So there are 6 run levels in Linux. So the init has a file called init tab, which determines which is the run level it has to start. So what is a run level, right? Run level determines which programs can execute after the OS boots up, which are the services that need to be started up. That's what is run level. So Linux supports 6 run levels, or 7, right? Including the 0 or halt, which is shutting down the system. And 6 is reboot. So 1 is single user mode. It is actually only for root login. You can't do anything else. It's single user. It does not even start the network interface. 2 is multi-user, so where you can have many users logging in, right? It does not start daemons. It does not configure the network. 3 is normally the one which gets started, which is multi-user mode, start the system normally. 4 is not defined. 5 is X11, which is the graphical user interface that you see. It is like similar to run level 3 plus the graphical user interface. And 6, as we saw earlier, is the reboot. Now, when you configure Linux, you can decide what is the mode in which you want to start. Do you want to start in a single user mode, multi-user mode, or multi-user mode with networking, or with the GUI display, right? You can define that as in a file called etc/init tab. So if you open that file, the run level is configured, and etc/rc0.t will have the files for run level 0. rc1.d will have the files for run level 1. We'll see that in a very short time. Once the services are started as per the run levels, then the command, it waits similar to a Windows. It waits in a prompt or it waits in a shell, right? Depending on the run level that you've configured. So this is the boot process for a Linux system. Next, after that is done, right? So now we have to look at the commands which are part of each of these, right? So memory management, scheduler, file system, input output, process management. We need to look at each of these. Now let's start with the file system, right? So what is a file system? What does authentication authorization mean? Let's look at that first. So to look at that, we need to log in into a Linux system. What I've done is, just so that you don't have to configure a Linux box, right? There is a JS Linux which is available on the web. You can go to Google and search for JS Linux. You will get this shell prompt. It might take a few minutes for it to boot and then give you a prompt. but once it is there, you have a shell prawn. Now, what is a file system? File system is a collection of files and folders, right? So you can create a folder, mkdir tmp, right? I'm creating a temporary. I can go into that directory. Now, where am I? /root/temp. So this is a directory structure. So there is a master folder called root. So Linux starts with the slash, right? The /, which means root. So you can go to the root directory. In that root directory, you will see a set of directories available below that. Each one is a directory. In Windows, you call it as folders. In Unix or Linux, you call it as a directory. And you can go to any directory, for example, the home directory or the root directory. You can go to any directory. There you can create your files, right? So right now we can look at the number of files which are there. So if you look at it, there are we have 4 files here. So 2 files, hello.c, which is a C program, temp, which is the directory we created, DOS is another directory that is there. So directories usually have a different color. It might be green in some systems, it is blue in some systems, but directories are different. So directories can save files inside. It is like folders having files inside in DOS or Windows. So similar to that, here directories can have files, directories can have subdirectories, it can be a hierarchy, right? This entire thing is managed by the file system. Now, file system manager, what it does is, it tells you what is your present working directory. So I have logged in. When I do cd, I am taken to my home directory. So this is my home /root. Now under this, I can create a directory, right? mkdir will create a directory. I can create a directory here. I can go to temp1. I can create one more directory, temp1/level2, right? This is second level directory that you have. Oops, sorry. So mkdir, in Unix it is, Linux it's /temp1/level2, right? Oops, mkdir temp1/level2. That means from the current directory where I am already in temp1, that's why it's not allowing. I can do just a level 2. So level 2 is created. Now if you look at where I am in root/temp1/temp2. If you want to go to the parent directory, cd space .. It will take you to temp1. If you want to go to the root, you can do .. You are on root. If you want to go to the parent directory, it is /, you can be there. So this is how you traverse across directories, right? So you can go to dev. Dev has a list of files which are terminals. These are terminal windows. TTY is terminal, and port, random, you have a lot of terminals available. There are character terminals and block terminals, which are block devices which are available. So dev is one. As we saw earlier, you have etc. I had mentioned that you will have init tab, right? So let's open the init tab. We saw this earlier. So this is where you define the run levels, right? This is the file which is there. We're not going to go into the details of this particular file to explain this entire thing, but this is where usually you define your run levels in which the system has to boot. So now this is where we are, right, in etc directory. So you can go across directories, you can go across files, and then you can explore the files. If you want to, for any directory, right, you want to find the list of files, ls is the list of files. If you want a longer listing, you can do ls-l. So there it gives you the permissions, it gives you the size of the file, when it was created, and the file name, right? So we'll talk about the directory permissions next. What you see here, we'll see next. But before that, this is -l. There are various other options. LT means it is like by time created, when it was created. Based on that, it will do a sorting. For example, December 9th, I just now created temp and temp1. So that's what you see at the top, and August 21, it was created long back. So you're seeing it at the bottom. So you can do a long listing based on this. Now let's try to understand what you see here, right? So you see here 10 letters. So the first one is D or hyphen. D means that is a directory. For example, temp1 is a directory, so it shows a D here. Hyphen means it's a normal file, right? So this is hello.js or hello.c are normal text source files. They are not directories, so that's why you see a hyphen. Next you see rwx, okay, then you see r-x, then you see r-x. What are the three things that you see here? First, rwx represents user. Second, the permissions for the user. This is the permissions for the group. This is for permissions for the others, right? You can have a set of users within a group. For example, a class of computer science students can be in a group. Now what it says is Linux helps you define what is that each person has. So for example, in this particular file, the owner of the file, which is me, I have an option to read the file and write the file. I can overwrite whatever is the content in that file. But anyone in my group, right, which is this, can only read the file. They cannot write the file because W is empty now. And they cannot execute the file. Even I cannot execute. There is nothing to execute. It's not an executable file. It is a source file. Let's create an executable, right? I'll compile this hello.c, gcc hello.c, right? Compiled, it will create a file called a.out. Now that a.out file will be an executable file. We'll do a long listing of a.out and then see what is the output. But before that, if you see, directory is there. Here again you have read, write, execute. What is the others part, right? R hyphen. What is the others here? Others are people who are not in this, user is not in the group as well. So that hello.c is now compiled. If you do a long listing, you will see hello, there is a a.out. A.out is an executable file. That means I can run it. Okay, I can run it. That's what is executable. So if you see, I have read, write and execute permissions. Others in my group have read and execute permissions. And people who are not even in my group, which is considered as others, have read and execute permissions. Now you can change the ownership of who can read and write. Let's do that. I've just changed the size of the window so that's easier. So I'll clear this. Okay, so we have ls minus l a.out. If you see a.out, it has read, write, execute for user, read and execute for group, read and execute for others. So you can change the permission. So chmod is the command to change the permissions. So there will be three numbers you will give. What are the three numbers? So this R has a value of 4, this W has a value of 2 and X has a value of 1, right? So for example, if you want to read and write alone, right? So you can give 6, that is 4 and 2 combined together is 6. And only for the user, for the group and others, you don't want to give any permission. So you'll give them as 0, 0. Now if you look at it, you will have read and permission only for the user for that particular file. You will see read and write only for that user. Now you want to give read, write and execute permissions for yourself, right? So let me first run it. You will see that permission is denied because execute permission is not there for the user, even though I am the owner of it. So I'll now do a 700 a.out. That means I've given read plus write plus execute. So you can see that ls minus l a.out, read, write and execute, all three permissions are given. Now I'll do /a.out, it will work fine. But anyone else in my group currently will not be able to access this file. So how do you actually give read and execute action to others? Chmod, for me I want all the access. Let's assume I want to give read and execute. So 4 plus 1, 5 to the group as well as others. So I'll have to give 755. Now what will happen? RWX, R-X, R-X should come. Let's see that. Yes, that's what has come. RWX, R-X, R-X has come. That means anyone in my group can execute this, and anyone in the others can execute and read this file as well. So reading means you can open it and then read the file. That's what it means. So similar to change mode, you have ch group, you have ch own. These are three commands which are there. Ch own is used to change the ownership. Ch group is to change the group from which group the file belongs to, right? These are some commands available. Now within the file system, the other commands that we have is, let's take hello.c, right? I'm going to count the number of words in hello.c. So WC will give the number of lines which are there, which is 16, number of words which are there, which is 38, and number of characters which are there, which is 242, right? That is word count. So the other thing is you can search for a particular string in a file. Say I'm doing a grep. Grep is to search for a particular string within a file. grep hello in hello.c. So if I search, there are two lines in hello.c which have the word hello, right? So I can, yeah, this is hello.c. If you see, there are two lines here which have the word hello. So both those, I mean small h, right? So hello is here, hello is here. This hello does not match because it is capital H. So grep is used to search for a particular word in a file. There is something called redirection. Let me use the ls-l command and I want to pipe it and send the output to word count. So what it does is ls-l lists all the lines, right? So there are totally 10 lines here. So ls-l pipe to wc. This is called pipe. The output of this command is sent to wc, right? And wc takes this as an input and counts the number of lines, number of words, number of characters which are there. So this is called piping. There is something called redirection as well. So ls-l greater than t.txt. This is called redirection. Greater than symbol means this output is taken and put into this file. For a piping, you need to have both as commands. ls-l should be a command and the output should be sent to another command. For piping, for redirection, ls-l, it will save it in this file. Now if you open t.text, right? So I'll do a cat t.text. You'll see that the output is stored in this particular file. So ls-l is the same content. So this ls-l content we redirected and stored in this t.text, and that's what we have printed here. So this is again very important. Cat is a command which is used to display. I've already used it a couple of times. It's used to display the content of a particular file. If you do a cat hello.c, it is going to display the content of a particular file. So this is again very important. If you want to display only the first few lines, hello.c, head hello.c, it will display the first 10 lines of hello.c. Similarly, tail hello.c will display the last 10 lines of hello.c. So these are all related to files. An easy way to create an empty file is using the command touch. If you do touch new.c, it's an empty file, it gets immediately created. And if you want to copy the content of one file to another, copy hello.c to hello1.c. This will actually, if you see hello.c, hello1.c, both are getting displayed. So hello star.c is wildcard character. So anything which starts with hello and any number of characters followed by .c, right? Only those files get displayed. So here hello.c and hello1.c both have exactly same content. So you can rename a file as well. So we had hello1.c. I want to rename it to hello2.c. mv is the command which is moving hello1.c to hello2.c. It is not just rename. If you look at it, temp1 is a directory, right? Irrespective of the number of files which are there in temp1, you can move temp1 to another name. That means all the content, everything is getting moved. The name of the directory gets changed, right? So that's what is move command for. So you can delete a file as well. rm hello.c will delete hello.c, right? You can remove the file. It will no more be part of it. So now hello2.c I can copy to hello.c. So these are some of the important commands that you will use. I think you have to use it multiple times for you to get familiar with it. But I think we have discussed the most important commands which are part of the Linux file system command set. So let's quickly summarize that. So I've listed down some commands here. ls to list the file, ls-ls long listing, cat to display the content of a file, cd to change the directory, pwd to print the current working directory, mkdir to make a directory, rmdir to remove a directory, chmod to change or modify the permissions of a file, change ownership is chown, changing the group is chgroup, Head will display the top 10 lines of a particular file. Tail would display the bottom 10 lines of a particular file. Grep would search for a particular word in a file. WC will count the number of lines, words and characters in a file. MV will help in renaming a file. CP will help you copy a file. So there are plenty of commands. I'm sure these are the most important ones, but I'm sure there are a lot more commands which are there, part of the Linux. This one you can search on the web for additional commands, but the most often used commands are these. Now that we have seen the file system commands, let's look at the process part, right? So from the process standpoint, so for the process management, some of the important commands which are there are PS is a very important command which lists the current processes which are running in the system. As we talked earlier, right? Process ID 1, PID is the process ID, 1 is the init process that we already saw, 2 is the kernel thread process that we saw, right? 0, which is the swapper or the pager, is part of the kernel itself, right? So these are all the processes which are there. If you want a longer listing of the process names, you can do a PS-AL. This will list you details of all the processes which are there. Next is you can kill any process you want, right, using the PID. Say let's take any process, kill 57 or 40, right? I'll do kill 40. That will kill. It will send a signal to that process to kill, right? So SIG13 would get sent to terminate that process. That's kill 40. So the process ID 40 will get killed based on this. So now you can, the PS is 1 for this, kill is going to kill. Top is a command which is used to display the process which is occupying the most time as of now, most CPU time as of now. So top will continue to run unless you come out of it. You have to do a Control C to come out of the top process. Top lists all the processes which are there with the corresponding utilization time of the CPU in that. So this is the top. Last command that we will see on the process management side is the nice command, right? So you can give a nice. So nice command is used to reduce the priority of a process. So every process is given a priority, right? Based on that priority, it will be scheduled for CPU time. If the priority is low, it will take a longer time to get the CPU time. If the priority is high, it will be given CPU time quickly. Nice is a command where you can say that I want to reduce the priority of my process so that I don't want CPU time immediately. So that's the nice command. So I think with this, we have a really good look at, we have looked at the process management as well as the file management commands. Input output, you do it using C, right? Scanf and printf that you already know. So operating system takes control of maintaining a buffer for a process and getting the keyboard input into the keyboard buffer. That's managed by the Linux kernel. So again, authentication and authorization, every user having a user ID and password is managed by the Linux kernel. Coming into your memory management, having a dedicated memory management unit is very important for virtual memory management. So the paging concept is completely implemented. It is done in Linux. The other important area in Linux that we need to talk about, which is unique compared to Windows, is IPC, right? That is inter-process communication. So Linux has three major forms of communication apart from the traditional sockets. One is using the direct pipes. It's called named FIFO or pipe. So you can use a pipe to send messages between processes. Second is you can use message queues. You can establish message queues to send between two processes. Third way to communicate between processes is you can have a shared memory. So two processes can attach and share a memory and they can send the messages to each other through the common shared memory. So this is called inter-process communication. You can lock, unlock and make sure that that process is synchronized as well. So this entire thing talks about the inter-process communication. So with this, right, we'll close the major aspects of Linux. I hope this session was really useful to you. This was not an all-exhaustive Linux tutorial. This is supposed to provide you the basic introduction to Linux and for students to go and attend interviews. This section covers the most important questions which are usually asked in the interviews. These commands that you need to know is covered part of it. The one thing that we did not cover is the editor called VI editor, which is very, very popular in Linux, right? So I would suggest you going to online GDB or one of these systems and use the VI editor to get more familiarity with the editor. It's a very, very powerful editor, similar to any of the Eclipse IDEs that you have used. VI is a very popular editor and in the Linux environment. Thank you all for staying with me all this while. I hope this session was useful. If you have any comments, please add it to the comment section. Thank you.